All right, now we're going to talk about another special matrix. The special matrix we're going to talk about now is a vector. Okay, this is a special matrix because as a vector is when m or well, let's say m equals 1 or n equals 1. All right, so this is a vector, and so when m equals 1, so we say when m equals 1, that's going to be a 1, and then there's no m only equals 1, so there's no second row. It's all in one row, right? So then we can have a 2, well, it would be a 1 2, a 1 3, a 1 4, right, all the way to a 1 m. Excuse me, not m, but n, a1n, right? Because n isn't equal to 1. And so this is a row vector. Now, we also have the case of a column vector. Column vector is when n, so this is, I forgot to write this. So row vector is when m equals 1, we have a row vector. When n equals 1, we have a column vector. When n equals 1, and so that corresponds to a 1. And so what we'll do here, though, on the vectors is, this is 1 1, right? Is we drop the 1, right? Because it's a1 1, a1 2, a1 3. We know that there's only one of them, and so we call it a vector, and we reduce it to 1 notation. The same thing we do here. We say, well, this is a1, and of course it's row 1, and we know that this is row 2, but we're just going to call it a2. I mean, it is row 2, but we know these are all column 1, but we don't specify them as column 1, and so then this is just it should be am, right? But since no n, no, it's an, and yes, it should be am, right? No, it should be am because there are m different rows. But again, when we have a vector, sometimes we drop this one notation, and so we just call it an. I know it can be confusing, but that's what we do. I wish we didn't. I wish we just used m and n consistently, and if they're m equals n, we just call it an m by m, but we don't do that. Okay, so this is what we do. This is the second special type of matrix. Let's redo that. Special type of matrix, a vector.